Okay, today we're in 6.2, and although this looks like a mess, each one of these lines is graphed in a different color. Okay, except for it looks like this one. Well, let's see. This one right here, I'm going over in purple. Okay, so we're finding the slope of each one of these lines. Okay, so we're going to be using slope triangles for this. We'll start with the green line up there on the top. The way that you find the slope from a graph is to pick out 2 points where the line goes through the diagonals of each square. So it looks like one of those points is right here, and another one is right here. Okay, so I'm going to see, going from the left point to the right point, what the slope is. Remember, slope, for some odd reason, it is a small m that designates slope. Slope is rise over run. So rise is either up or down. Run is either right or left. Okay, so rise is not just going up. It could also be going down. So when we go to find the slope, you start with the point on the left and you work your way over to the point on the right, regardless of whether your slope is going down or going up. Okay, so we need to work from this point over to that point. Okay, so in order to get from the point on the left to the point on the right, we have to go down 1. So the green line, we go down 1 and then over 1, 2, 3, 4. So the slope of the green line is -1/4. Okay, so I'm going to erase that to get it out of our way. Okay. And just kind of reconstruct here. Okay. Now let's look at the red line. Okay. We're going to do the same thing. We're going to pick out 2 points on the red line where it goes through the intersection of the grid marks, which I'm going to say is the starting one right there. Let's just pick that one right there. And this one down here. Okay, so we are working from that point on the left down to the point on the right. Okay, so we have to go down 1, 2, 3, 4, 5 to get to where we are even with that point. Okay, so we went down 5, and then from there we go right 1, 2, 3, 4, 5, 6, 7. Okay, so the slope of the red line is -5/7. So I'm going to erase the red line. Okay. And then we'll work on the purple line. Okay, so I'm going to use a different color so it shows up. Okay, so we'll work from that point right there to this point right here. Remember, the point on the left is where you start, and you work your way over to the point on the right. So in order to get from this point to this point here, we have to go up 1, 2, 3. So we went up 3 and then over 1, 2. Okay, so Up is positive, down is negative. Right is positive, and left is negative. Okay? Those are the kind of like the directions, okay, for each one of the slopes. Okay, so we're just kind of knocking out these lines here. And next we'll do the pink line. That's the only one left. Okay, so we'll pick 2 points on that line. It looks like this one right here and this one right here. So we'll start the point on the left and work our way to the point on the right. So we will go up 1, 2, 3, 4. We went up 4, and then to the right 1, 2, 3, 4, 5, 6, 7. So the slope of the pink line is positive 4/7. So positive slopes go up and negative slopes go down. Okay? Now, for coordinates, when we're not given a graph to look at, we have a slope formula, and it is right here. So y2 minus y1 over x2 minus x1. Now remember, the y is your vertical axis. So like that's your y-axis right here, and this is your x-axis right here. So y being up and down is the rise part of the slope. X goes from side to side, so that's the run. Okay? So we look to the y coordinates over the x coordinates, because remember, slope is rise over run. So it's the y information from each coordinate over the x information from each coordinate. So here's what we're going to do. We're going to go to these 2 coordinates here starting out, and we're going to label them x1, y1, and x2, y2. Now, trust me when I tell you that if you called this set of coordinates over here, 9, 6, if you called that x2, y2, and then these over here were x1, y1, you would still get the same slope, no matter what, I promise. Okay, so we're going to apply the slope formula. y2 is 4 minus y1, which is 6, over x2 is negative 3 minus x1, which is 9. So 4 minus 6 is negative 2, and negative 3 minus 9 is negative 12. Okay, so negative divided by a negative is a positive, and that fraction reduces to 1/6. So the slope between these 2 points is 1/6. Okay, now we're going to do the same thing with the coordinates on the bottom. This time, let's just call that x2, y2, and this then would be x1, y1. Again, it doesn't matter. Okay, so y2 is 7, y1 is 0. So y2 minus y1, x2 is negative 6, and x1 is negative 2. Okay, so 7 minus 0 is 7, and negative 6 minus a negative 2. Remember that that is like distributing a negative 1 into a negative 2 by multiplication. So negative 1 times negative 2 is a positive 2. So negative 6 plus 2 is negative 4. So the slope is negative 7 over 4. Because remember that it doesn't matter if your negative sign is on the top or the bottom or just out front. All three of these are exactly the same. So 7 over negative 4 is the same thing as negative 7 over 4, which is the same thing as just negative 7 over 4. Okay? So your slope formula. Do not put the x's on top because that is not the correct way to work the formula. Rise over run implies out of necessity that the y values go on top. Okay, now we are looking for the slope of the blue line and then that, I don't know, burgundy colored line, okay? So we're going to find the slope of the blue line. Let's just pick 2 points here. We'll pick this point right here and this point right here and find the coordinates. The coordinates of this point here, x value of 1, y value of 3. Over here on the left, we have an x value of negative 1, 2, 3, 4, and a y value of 3. Now let's use those coordinates and find the slope of the blue line. So let's call this x1, y1, x2, y2. So y2 minus y1 is 3 minus 3, and x2 minus x1, so we get a 0 over 5. 0 over any number at all is equal to 0. Okay, so a 0 slope means that there is no slope at all. Slope is, putting it in easily understood terms, slope is the amount of angle a line has, or gradient, or grade, whichever term makes the most sense, okay? A perfectly horizontal line has no rise at all. It's got a lot of run, okay? It'll go forever to the left and forever to the right, but it has no rise at all. So no rise equals a 0 slope, okay? So remember, any y equals line is a horizontal line. And what's the most important thing is that the slope of any horizontal line is always 0, always. Okay, so now let's look at the burgundy line, okay? So let's pick this point right here and this one right here, and we'll apply the slope formula. Okay, so the x-coordinate is 3 and the y-coordinate is 2. And the point on the bottom, the x-coordinate is 3 and the y-coordinate is negative 1, okay? So this will be x1, y1, and x2, y2. So the slope, y2 is negative 1 minus y1, which is 2, over x2 minus x1. So that gives us a negative 3 over 0. Well, you should know by now that you are never allowed to have a 0 in the denominator of a fraction. That means that that fraction is undefined, okay? So any vertical line is an x equals line. So an x equals line is a perfectly vertical line. And what's important here is that the slope of any vertical line is always undefined. Okay? Always undefined. Horizontal lines have a slope of 0. Vertical lines have an undefined slope. Okay? Now, we are going to do some graphing with some very basic information here. Okay. It says graph the line that goes through this point right here that has a slope of -3. Okay, so the first thing we're going to do is graph that coordinate point. X is 6 and Y is 2. So 1, 2, 3, 4, 5, 6, 1, 2, and here is our point, 6, 2. Now our slope being a -3 is, remember, slope is rise over run. So we can change that just -3 slope into a fraction. So the rise is -3 and the run is 1. So the -3, we're going to go down 3 and then we're going to go to the right 1. So from our point 6, 2, we'll go down 3, right 1, and make another dot. That gives us this line right here. Okay, and make sure that you make it long enough so that it is in fact a line. Okay, again, same idea. We will be graphing a line that goes through -1, 2 with a slope of -1/3. So we'll graph that coordinate, -1, 2 is right here. Now our slope, so here's what we're going to do. We are going to use a slope where the 1 is negative, and we'll put a point on the coordinate plane. Then we will do where the 1 is positive and the 3 is negative. Okay, so let's start with that slope right there. Okay, where the 1 is the negative value. So that means we'll go down 1 and then right 3 and make a dot. Okay, so we'll go down 1, right 3, and here is that coordinate. Now, likewise for that slope over there. If the 3 is negative, that means the 1 is positive. So we'll go up 1 and left 3. Instead of down 1, right 3, we're going up 1 and left 3 from our original point. So we'll go up 1, left 3, and there is that coordinate right there. As you can see, those are on the exact same line. So if I connect those points, you can see that those points all fall on the same line. So that goes back to, it doesn't matter where you put the negative, on the top number, on the bottom number, or out front. Okay? You'll still get the same line regardless of where you put the negative sign. Okay, that's it. Very simply. And don't forget that if you're graphing lines, which you are, you need to be graphing them on graph paper. I will not be grading graphs that are loosely and sloppily drawn on notebook paper. Don't forget that. Okay,